going to do this throughout the year. This is HSPT practice. This is a great way to prepare yourself for the high school placement test that many of the private schools have you take. You see that there are questions 61 through 112. Whew, that's a lot. And you have to do it in 30 minutes. So let's do this. 112 minus 61 gives us 51, so that's 52 problems in 30 minutes. So the first thing you need to be aware of is that when you take these assessments, you have to be so familiar with the questions. You need to know exactly how you're going to tackle them, and you have to do it, and you really got to be very efficient. So we're going to do 10 problems today. We're going to just do 10 every session. I think 10 is reasonable. There will be a worksheet, but this is the video explaining each of those 10 problems. So let's start. The quantitative skills. So it says, what numbers should come next in the series? So the series is 4, 12, 20, 28. So the first thing you want to do is you want to see, what are we increasing by? So what is that series? They call that a step. So what's the step? Well, it looks like the step is plus 8. So in order to get the solution, we're going to add 8. 28 plus 8 gives me 36. So the answer is going to be 36. And that's something, we know series, we know how to do that. So that's something that we should be, that question should take us, 20 seconds. Good. Next question. Examine the rectangle below and find the best answer. So we know it's a rectangle, so this is a key word, rectangle. We know that the sides are parallel. We use that sign. We use this to show that the sides are parallel, and then we use a double arrow like that to show those lines or sides are parallel. So rectangles have 4 right angles, and opposite sides are parallel. So what do we know? We're going to look at this. So examine the rectangle and find the best answer. So what we want to do is go through these relatively quickly and discard the ones that are not going to be logical. AC is bigger than BD. So AC is bigger than BD. So we're talking about diagonals. And diagonals are always going to be equal. So we know that that's not true. And look, we need to understand that rectangles don't have to be, a square is a rectangle. So those diagonals are all set. So those are rectangles. Rectangles can be longer than they are wider, but they can also be equal. So what's it going to be? AC is equal to BD and bigger than AB. Ooh, that's a real good one. So we know AC is equal to BD. We know that's true. Now, let's take a rectangle is the extreme. So if we look at this as a rectangle, so this one over here, let's move this. Right, this is going to be AB, A, B, B, C, and AC. So AC is equal and bigger than AB. We know that this is called the hypotenuse. We know the hypotenuse is always going to be the longest leg of a triangle. So when we look at this one, even in the extreme, this is the extreme, meaning that these sides are going to be the same. We know that this technically is going to be A rad 2 or X rad 2. That you'll learn a little bit later, but we know that it's more than X. And this is the hypotenuse again, and the hypotenuse is always the longest leg in a rectangle, or in a triangle. Okay, in a right triangle, the hypotenuse is always along this side. So that looks good. I would assume that the answer is going to be B, but I'm always going to check the other two solutions just to make sure. If I come up with two, then I have to look and see, did I misinterpret something? So let's look at C. BC is bigger than AB. So BC is bigger than AB. Well, we don't know that. BC is bigger than AB and bigger than BB. So I'm not able to judge that. I don't know. It didn't give me any information. They want you to suppose that because in the drawing it looks like BC is longer than AB. But remember, it just says that it's a rectangle, and we know that rectangles can be squares. So we know that these side lengths are going to be the same, so that would not be true. This is probably the most common wrong answer that people get. But that answer is wrong because we don't know anything about BC compared to AB. Let's look at D. AB is equal to CD, that is true, and equal to BD. No, it can't be equal to it. It will never be equal to it. And because that's the hypotenuse, and it will always be greater than any of its legs. So this hypotenuse, AC, we always know that that is going to be greater than any of the legs of its of the vertex that it's connected to. So we know that the hypotenuse is going to be bigger than this leg and bigger than this leg. We know the hypotenuse is going to be bigger than this leg and bigger than this leg. So that's nice to know. We see that D is not correct. So I'm fairly certain about B. Now that did not take 30 seconds. But that's only because I had to go through all of the reasoning behind it. But here's a good thing, right? You know rectangles, but look at all the little nuances that I spoke about in order to be able to make those decisions about C, D, and A to disregard them. So that's what I'm talking about, knowing things inside and out. You can't just know it to the most basic component. You need to know it inside and out in all of the little things about it. Let's look at number 63. What number divided by 2 is 2/3 of 39? So we have a number. So we have a number n, and we're going to divide it by 2. And it's equal to is 2/3 of, remember in our translating, of means multiplication, 39. So I was able to transcribe that written statement into an algebraic statement. So what I want to do is I'm going to simplify that right side. These are fractions. So 3 goes into 39 13 times. 2 is in the numerator, 13 is in the numerator. I have n over 2 equals, and that's a 1 right there. 3 goes into 3 one time, 3 goes into 39 13 times. I have 2 times 13, which is 26. And now I want to solve for the variable. 2 is dividing n. What's the inverse of dividing by 2? Multiplying by 2. And that leaves me with n equals 52. 26 times 2 is 52. Let's go up here. I have my solution, 52. And that should be less than a minute. That might take you closer to a minute, but between 30 seconds, and you're looking at it, you're transcribing it, and solving it. Number 64, examine A, B, and C and find the best answer. So we have A, which is 1/4 of, multiplying, 84. Then we turn 84 into a fraction. We're going to cross cancel. 4 goes into 4 once. 4 goes into 84 21 times. So we get A is equal to 21. 1 times 21 1 times 1, 21 over 1 equals 21. Let's look at B. 1/2 of 48 equals 2 goes into 2 once, 2 goes into 48 24 times. And C. 1/2 of 42. 2 goes into 2 once, 2 goes into 42 21 times, and then we get 21. Now, we're going to compare. Is A greater than B? Nope. A is not greater than B. Is A equal to B? Nope. Is B greater than A? B is greater than A, and is A equal to C? Yep. I like that. And let's check D just in case. Is B greater than A? Yes. Is A greater than C? No. So we get that answer. 65. What number should come next in this series? This is tricky because you don't necessarily see a 3 over here. A lot of people would just start with a 6. But you notice that in the first problem. So let's look. What's the step? What are we increasing by? So that is 3 plus 3. That is plus 6. That is plus 12. So since these steps don't increase the same, it is not linear. Let's go back to this first one. This, because each one is the same, we know that this is a linear equation, meaning I could write an equation to represent this series. So if this is the first, this is the second, this is the third, this is the fourth, we could say, how do I do the fifth? Well, we look and see, and that equation would be y equals x plus, not x plus 4, but 4x. There we go. So when I plug in 1 in the series, this number, we plug in 1, we get 4. Plug in 2, you get 8. Ah, so that was not correct. Well, my step is 8. Plug this to math, that wasn't very smart. So that's my step. Is 8 minus 4. Does that make, does that work? 8, plug in 1. I'm on a tangent. This is not what we should be doing, but it's okay. This is still okay. 1, and you get 4. 2, 16 minus 4 is 12. Plug in 3 is 28. 3, 24 minus 4. Good. And then plug in 4 is 32 minus 4 is 28. Plug in 5 is 40 minus 4 is 36. So that's how we do it. Sorry about that. And the reason how I do that, this is the step. This number always is the coefficient of x. Right? This number is always going to go in there. And then the cool thing is we go backwards. Well, if you subtract 8 to get to 0, if you subtract 8 from 4, you get negative 4. And that's where this number comes from. That number goes in there, and your step goes in front of the x. It's a little trick. Sort of sat there and fiddled around with that. So, going back to number 65 after that distraction, we notice that this is nonlinear. It's a nonlinear equation, or it's nonlinear growth. So, how do we see? What's happening here? Well, there's 3, 6, 12. Okay, what do you think the next increase is going to be? I think it's going to be plus 24, would be my guess, because I'm noticing that plus 3, plus 6, plus 12, plus 24. All right, so if we add 24, what are we going to get? We're going to get 48. 48 is solution. Yes, it is. Good. And then, so we see that 3 plus 3 is 6, 6 plus 6 is 12, 12 plus 12. So we're just multiplying it, or multiplying it by 2 or adding itself to itself. These are nonlinear, so you are not always going to be able to find what the 10th term in the sequence is. We may have to just do it one by one. But 48 would be my answer. I'm not sure if I explained that extremely well, but we'll keep practicing. There'll be other ones like this down the road. Number 66, examine A, B, and C, find the best answer. So I would first look and see A has, what's it, 4 by 3, that's 12. That's 4 by 3. This is 6 by 2. So B has 12 also, and this is 4, let's see, 5 by 4, so C has 20 boxes. Let's look at it. A has as many squares as B, yep, and fewer than C, nope. A has more squares than B, no. B and C each have more squares than A, nope. A, B, and C each have the same number of squares. No. All right, so when we get into this situation, then you have to look and did I make a mistake? Let me check my work. I absolutely am moving fast. I'm trying to be efficient. But when you move fast, you tend to make mistakes. So I'm going to check my numbers. 1, 2, 3, 4. 1, 2, 3. 4 by 3 gives me 12. 1, 2, 3, 4, 5, 6. By 2 gives me 12. 1, 2, 3, 4, 5. By 1, 2, 3, 4 gives me 20. So I did the boxes right. Now let's go back and see if I made a mistake. So let's go back to that. A has as many squares as B and fewer than C. There it is. There's my mistake. I misinterpreted that one. So yes, A and B have fewer than C. So A is correct, we know. And let's go through. A has more squares than B. Nope. B and C each have more squares than A. Nope. And A, B, and C have the same number of squares. All right. Nice little silly mistake right there. That's when you're rushing too fast and your reading comprehension is extremely important. But I like that we ran into the situation where we couldn't find the right answer. What do? You go back and quickly check your work. What number should come next in this series? We have 4, 8, 12, 16. Nope, we increase by? We increase by 4, by 4, by 4. So we would assume that we increase by 4, and 20 would be the answer that I would select. Again, that took 10 seconds. Examine A, B, and C. Find the best answer. 20% of 60. So there's two ways of going about doing this. 20% we're going to have to convert. So you can either convert it to a decimal, or you can convert it to a fraction. I think in this case, converting it to a fraction is probably best. And we know that we can reduce that to 2/10 times 60. I like this. I can cancel the zeros, and I end up with 12. So remember, we're looking for situations that are efficient. So B is 60%, 0.6 of 20. I could multiply those two, and 6 times 20 is going to give me also 6 times 2 is going to go here. There's two ways. So you have this decimal place and you have this 0. So that's 6/10, and that's 2. That's a 0 in the numerator. So they will cancel each other to give you 6 times 2. It's a little advanced, but if you want to get familiar with that, that's a good way. Or you can multiply 0.6 times 20 off to the side. That's probably too much work. Or you can do 60% is 60 over 100 times 20. You again can cancel the zeros. Those zeros cancel. This one's in the numerator, this one's in the denominator. This one's in the numerator, this one's in the denominator. They cancel. And then you're left with 6 times 2, which equals 12. So B is 12. And let's look at C, 200%. 200% converted to a decimal is 2 of 6, which is 12. 200% is 200 over 100. And again, the zeros cancel, and you're left with 2 times 6, which equals 12. So A is greater than B or C? No. A, B, and C are all equal? Yes. A is equal to B? Yes. A greater than C? No. B is less than A? No. So my answer is B. 20% of what number is 5 times 3? So we're going to translate that. 20% of what number is 5 times 3? 20% is a decimal or a fraction. Let's do decimal. 5 times 3 is 15. So what do you do here? 0.2n is multiplying n. What is the inverse of multiplying by 0.2? Would be dividing by 0.2. That leaves me with n on the left side. Here's a fun one. When you get a fraction and a decimal in there, what you can do is you can move that decimal point over one place, and the decimal point on 15 is there. You can move the top. Whatever you do on the bottom, you've got to do to the top. So you get 150 over 2, and half of 150 is 75. That's one way of doing it. That's it. So you get 75. So I say the answer is D. And number 70. My series is 5, 8, 12, 15, 19. What am I increasing by? That's going to be plus 3. That looks like plus 4. That looks like plus 3. This looks like plus 4. There is no mathematical equation that you can write for that, but you see the pattern. 3 plus 4 plus 3 plus 4. So we know the next one is going to be plus 3, which would give me 22. 22 is a solution that we can do. There's really no testing. You can't really discard A or C or D. You just got to stick true to your notes and your work. All right. So those are the first 10 problems. We will continue to do problems like that. I will give you hints and suggestions on how to become more efficient with HSPT. Hope that helps. Look forward to doing more with you on another Friday.